Whoa, guys, look at the moon.
Oh my god, this is definitely not normal.
It's getting bigger.
I think it's getting closer.
I'll get my binoculars.
Imagine this. The moon explodes, splintering into 7 large pieces. It is unknown who did it or why. Before long, the 7 chunks collide and quickly disintegrate. The debris falls towards Earth, enters the atmosphere, and heats up the planet to the point where it becomes uninhabitable for the next 5,000 years. This terrifying scenario is the opening premise of Neal Stephenson's science fiction novel Seveneves. Seveneves is classified as hard science fiction, which emphasizes scientific accuracy and realism. But how scientific is his moon explosion exploration? What exactly would happen if the moon exploded tonight? This concept is not as ridiculous as it appears. Moons do occasionally explode. This can occur in one of 2 ways. Either they are hit by a large object or are torn apart by gravitational disturbances. These 2 possibilities are not uncommon. The rings of our solar system's gas giants could have formed from the remains of exploded moons. When the solar system was young, bursting moons and celestial bodies were much more common. The solar system was a chaotic place at the time. Unlike today, when 8 planets follow regular orbits like clockwork, there were numerous small planets flying around. They would occasionally collide. The early Earth was almost certainly hit by another planet at some point, and it appears that Mars experienced something similar. Those collisions had to have caused spectacular explosions. The Earth was most likely ripped apart in the collision, releasing a massive cloud of debris. The debris cloud would have settled over time, reforming the Earth but leaving a large second object in orbit, our moon. Such collisions are now uncommon. Ceres, the largest known asteroid, would not destroy the moon if it collided with it. The second possibility is gravitational disturbances. The idea is that if 2 planets or moons get too close to each other, the force of gravity becomes strong enough to tear the objects apart. In theory, the Earth could do the same to our moon. If the moon were to get much closer to the Earth, to within 10,000 miles, the Earth would begin tearing chunks off its satellite. Fortunately, the moon is over 200,000 miles away, making such an event unlikely for the time being. However, it is not impossible. Billions of years from now, as the sun begins to die, it will begin to expand. The sun's outer layers could reach all the way down to Earth. This would cause the moon to slow down and fall towards the Earth. As it gets closer to the Earth, it will begin to rip apart before crashing into it. In any case, an exploding moon, at least by natural means, seems unlikely for the time being. That leaves artificial methods, most likely a massive bomb. It is not impossible to blow up the moon with a bomb, but it would be a massive undertaking. A single nuke would not suffice. Millions would be required. It's laughable that you could do that with no one noticing, but for the sake of argument, let's continue. So, what would happen if the moon blew up? Seveneves' scenario contains 2 assumptions. The first is to believe that a large portion of the destroyed moon will fall to the Earth. The second concern is that all of the debris burning up in the atmosphere will heat the Earth to the point where it will become uninhabitable. Let us begin with the first assumption. What would become of all the moon's debris? The answer is determined by the magnitude of the explosion. If it is large enough, the moon will be smashed to smithereens and all of its fragments will either be blown into deep space or crash into the Earth at high speed. That would undoubtedly be a bad outcome. However, the damage would be rapid and civilization on Earth would almost certainly be wiped out by massive effects, with anyone unlikely enough to survive dying of starvation before long. We can assume that the explosion is weaker because that doesn't occur in the book. In fact, the novel claims that the moon splits into 7 large fragments, which collide to form many more fragments. This implies a powerful enough explosion to shatter the moon, but not powerful enough to send pieces of it careening across the solar system. This brings up an important point. The moon's gravity does not vanish when it goes boom. As long as the majority of the moon's debris remains in roughly the same location, all of the mass remains and the moon's gravity does not change significantly. The implications are significant. The debris cloud will continue to orbit the Earth, and the moon will gradually reassemble itself. This means that the majority of the moon's debris will not impact the Earth. Instead, the moon's fragments will collide with one another, either breaking up into smaller fragments or merging to form larger fragments. The moon will eventually reform, carrying on much as before. But there's a catch. Some of the collisions will result in a few fragments being ejected clear of the lunar debris cloud. Consider the impact of a huge asteroid on Earth. The majority of the material remains on Earth, but tons of pulverized rock will be thrown into the atmosphere or into space. Some of the debris will completely escape the Earth and enter orbit around the Sun. The same thing would happen to the Moon's remains. Some of the debris may escape if the collisions are strong enough. So, what becomes of that rock? The majority of it will remain in orbit around the Earth, forming a shaky ring. However, some of it will be directed at the Earth, and a small portion will enter the atmosphere, with the majority of it burning up before reaching the surface. This is, in essence, what happens in the novel. How much debris would be required to make the Earth uninhabitable? Remember, this is the book's main plot driver. As debris falls to Earth, it burns up in the atmosphere. Gradually, the atmosphere warms until massive global warming forces humanity to relocate to orbital cities. Debris burning up in the Earth's atmosphere does, in fact, heat the planet slightly. However, under normal conditions, this effect is negligible. Every day, approximately 100 tons of space dust burn up in our atmosphere. Some of it is bright enough to form a shooting star, but the majority of it burns away invisibly. This dust contributes little energy to the atmosphere. According to preliminary calculations, the heating effect is around 60 megawatts, which is roughly equivalent to the power generated by 40 wind turbines. The Sun, on the other hand, heats the Earth with 170 billion megawatts, far more than space dust does. However, such massive amounts of energy are possible on an astronomical scale. A large asteroid, big but smaller than the Moon, could theoretically release enough energy to evaporate the oceans. Thousands of asteroids hit the planet billions of years ago, during a period known as the Late Heavy Bombardment. Some of those asteroids would have left continent-sized craters and possibly boiled off a large portion of the oceans. Debris from the Moon could do the same thing, if there was enough of it. To evaporate the oceans, billions of tons of lunar material would have to collide with the Earth. That may seem like a lot, and it is, but the Moon is also very large. A trace amount of lunar material would suffice. The Moon's gravitational pull slowed the Earth's rotation over billions of years, giving us 24-hour days. Without it, the Earth would begin to rotate more quickly. The days would be shorter and the winds would be stronger. Birds and insects would struggle to survive the high winds. Not only that, but ocean tides would begin to recede into tiny waves. Our entire world would be turned upside down. The Earth would burn up, our days would be shorter, and there would be no moon to illuminate the night sky. So that's the end of the video. Make sure to like the video, hit the notification bell, and subscribe to our YouTube channel for more amazing content. Until the next video, take care.